All right, today we are diving into what a lot of people are calling the next great leap in artificial intelligence. We've all gotten used to AI that can write, that can chat, and generate images. But what happens when AI stops just talking and starts doing?
And look, that's not just hype. That quote comes from Marco Argenti, the CIO of Goldman Sachs. For decades, we've seen AI go through these cycles of excitement and then disappointment. AI summers and winters. But according to the leaders right on the front lines, this time is fundamentally different. The entire game has changed.
So, what is this change exactly? Well, for the past couple of years, the whole world has been focused on building the engine, these incredibly powerful large language models. But now that focus is shifting. We're finally starting to build the car around that engine.
And that car? That's what we're calling an AI agent. We are moving from an AI that just generates plausible-sounding text to an AI that can become a true agent of action. It's a system designed not just to respond to you, but to actually achieve goals out in the world.
Here's a great way to think about this shift. Compare a static subway map to the GPS on your phone. Old AI systems, they were like that subway map. They followed a fixed path, and if there was a single disruption, the whole system just broke. These new AI agents, though, they're like a dynamic GPS. They can reason, they can look at the world around them, and if they hit a roadblock, they just adapt and find another way to get to the destination.
So let's get a little more formal for a second. An agentic system is a system that can perceive its environment, make decisions based on what it sees, and then execute actions all on its own to get things done. It's not just following some rigid script, it's using flexibility and even a little initiative to work towards a goal.
And these characteristics are really what make them so different. They have autonomy, which means they don't need a human looking over their shoulder all the time. They're proactive, they can use external tools like APIs, and they even have memory to learn from past interactions. All of this comes together to make them incredibly dynamic and powerful.
But, of course, when you give a machine these kinds of capabilities, you create both incredible opportunities and some pretty significant risks. So, what really happens when an AI can act completely on its own? Let me give you a taste of the promise. Marco Argenti tells this amazing story about asking an agent to migrate a website. For 20 minutes, it just went to work, asking questions, requesting credentials, giving him little updates. He said it felt like he was collaborating with a junior developer. And then, at the end, it delivered a fully deployable package. I mean, that's the magic right there. But that magic, it comes with a very serious warning label. The ability to take autonomous action in the real digital world means the stakes are suddenly much, much higher. The stakes become really obvious when you compare two different scenarios. Let's say an agent messes up a recipe for some wacky chicken salmon fusion pie. Okay, the outcome is a funny story you tell your friends. But what if an agent makes a mistake while executing a financial trade or handling sensitive client data? Now the outcome is a genuine crisis. The potential for real-world harm here is immense. And, these aren't just some far-off theoretical risks. There's already this darkly funny cautionary tale of a web automation agent that, after failing a login attempt, decided the most logical next step was to find and email a member of parliament to complain. It's hilarious, sure, but it is a stark reminder that we're dealing with a technology we don't fully understand yet. So if these agents are both incredibly promising and potentially perilous, how do we move forward, right? How do we harness all that good while controlling for the bad? Well, the answer lies in good old-fashioned engineering discipline. To move beyond just wild experimentation, the entire field needs a much more structured approach. The solution that's being championed is a set of agentic design patterns, a reliable, repeatable way to build these complex systems. So, what are these things? Well, think of them like battle-tested blueprints. Just like an architect uses proven patterns to design a stable building, developers can use these patterns to build reliable AI agents. It stops them from having to reinvent the wheel every single time for common problems like error handling or tool use. And this isn't just some abstract idea. The book this research is based on actually identifies 21 distinct patterns. Having a concrete number like that is really powerful. It gives developers a tangible toolkit and a common language, which allows them to build these systems more safely and reliably without starting from scratch every time. And look, this idea has some serious backing. Saurav Tiwari, who's a VP at Google, argues that these patterns are going to be foundational for the next era of AI, just like traditional design patterns were for software engineering. It's all about bringing a new level of maturity and discipline to the field. So, okay, having a blueprint is one thing, But how do we actually apply it responsibly? This is so critical, because the goal here isn't to replace humans. It's about augmenting our own ingenuity.
And the first rule is simple, but it is absolutely crucial. You cannot build on a messy foundation. You can't just drop a powerful AI agent onto a chaotic, inconsistent system and expect good results. An agent will only amplify what's already there. And if what's there is garbage, it's going to produce confident, plausible, and very dangerous garbage.
This means you have to do the hard, foundational work first. We're talking about investing in clean data, consistent metadata, building well-defined APIs. You have to build a modern interstate system that allows these agents to operate safely and predictably. It's about creating what's called a programmable enterprise, where all your processes are as well architected as your code.
And this all comes down to 3 core principles that should guide every single step. First, build with purpose. Solve a real problem. Don't just build technology for its own sake. Second, look around corners. Always anticipate how things could go wrong and design for that resilience from the start. And finally, inspire trust through transparency and being accountable for the outcomes. Which leaves us with this final, critical question. The race isn't just about discovering what's possible with this new technology. The real challenge, the one that faces all of us, is to figure out how we build what is right, what is robust, and what is truly responsible.